Do you know that climate change is one of the most serious issues humanity is facing today? The signs of climate change are becoming increasingly evident and severe, such as rising sea levels, melting polar ice caps, freshwater scarcity, natural disasters, declining biodiversity, widespread infectious diseases, and poverty. One of the main causes of climate change and global warming is the increase in greenhouse gases in the atmosphere, primarily carbon dioxide, methane, and nitrous oxide. So, how can we reduce the amount of greenhouse gases in the atmosphere to prevent the worsening of global climate change? One of the most effective solutions is to replace fossil fuels with renewable energy. Fossil fuels derived from ancient living organisms like coal, oil, and natural gas release a significant amount of CO2 and other greenhouse gases when burned for electricity or heat. Renewable energy is derived from continuous natural processes such as sunlight, wind, and water. When used to generate electricity and heat, these sources produce little to no CO2 or other greenhouse gases. However, transitioning from fossil fuel to renewable energy is not easy and comes with numerous challenges, including inadequate infrastructure to transport renewable energy from production facilities to residential or industrial areas. Are you ready to solve the problem by leveraging robots and advanced technology? If so, you can participate in the Myor robot competition organized by Garastem in collaboration with the Ho Chi Minh City Youth Union. The competition aims to encourage innovative high school students to design and assemble robots capable of transporting renewable energy to communities and industries. Join Myor 2024, where participants can register either as individuals or in teams of 2. Teams will compete on a board with dimensions of 2.4 meters in length and 1.2 meters in width. Along with the structural blocks arranged on the board, here are the positions for participants to observe. Position of 2 solar power plants. Position of 2 wind power plants. Position of the security gate. Position of the slope. 4 positions representing residential areas. 2 starting positions. Additionally, for the middle school board, there is 1 obstacle whose position will be announced on the competition day. These are the 2 possible obstacle positions. Wind power plant. This is the wind power plant housing the wind energy block, represented by the white ball. Solar power plant. Now we have the structure of the solar power plant containing the solar energy block. The solar energy block is the white ball with yellowed stripes. Participants should take note of how the solar power plant operates. Participants are only allowed to retrieve it after the energy is fully charged. The charging time is 10 seconds from the start of the round. Security gate. The structure features a barrier. When the robot is detected in security gate area, the barrier lowers after 5 seconds, then remains down for another 5 seconds before lifting for 5 seconds, and the cycle repeats. Slope structure. This is the slope structure. Participants need to skillfully control the robot to overcome the slope when heading towards the wind power plant. Residential areas. Residential areas are defined in terms of the maximum and minimum quantity of energy blocks. The exact quantity will be announced on the competition day. Fence structure. This is the fence structure. Note that in the residential area, the fence structure is placed on the red battery. If the robot collides and knocks down the fence, points will be deducted. Mission 1. Firstly, guide the robot to the wind power plant to retrieve the wind energy block. When the robot successfully retrieves the wind energy block, 15 points will be awarded for each block. If no wind energy blocks are retrieved, no points will be awarded for this mission. After obtaining the energy blocks, control the robot to the residential area to release the wind energy blocks. Successfully placing each energy block in the designated position will earn 30 points for each block. If an energy block is placed in the wrong position, the team will not receive any points for that block. Now, presenting Mission 3. Participants will guide the robot to the location of solar power plant and proceed to retrieve the solar energy block. Participants need to know that the solar energy block, they are only allowed to retrieve it after it has been fully charged. The charging time is 10 seconds from the start of the round. After being fully charged for each successfully retrieved solar energy block, the team will be awarded 10 points. If any solar energy blocks are not successfully retrieved, no points will be awarded. After completing Mission 3, control the robot to the residential area to release the solar energy blocks. Successfully placing each energy block in the designated position will earn 30 points for each block. If an energy block is placed in the wrong position, the team will not receive any points for that block. Participants have the freedom to choose the order in which they execute missions, depending on the strategic approach of each team. For Myor 2024, participants should know that both individuals within the same team must actively engage in the examination. The first team member will control the robot from starting position 1 or starting position 2 as randomly announced on the competition day. They will complete tasks 1, 2, or 3, 4 and control the robot back to the remaining starting position. The second team member will control the robot from the position where the first team member just controlled the robot back to complete the remaining tasks. Afterward, they will control the robot back to the starting position for programming tasks. After completing missions 1, 2, 3, and 4, with a minimum of 1 block for each task, the contestant will control the robot back to the starting position for task 5. There are 2 starting positions for the line following on the board to be announced on the competition day. The participant's task is to program the robot to autonomously navigate and find the path at the designated location, returning to starting position 2. Now, let's move on to the programming section of the middle school board. The contestant controls the robot back to the starting position for task 5. At the beginning of task 5, the robot's line sensors are placed on the black path. There are 2 starting positions for line following on the board, and these will be randomly announced on the competition day. After the robot successfully navigates back to the starting position, it will earn 10 points, and if the robot comes to a complete stop in the starting position, an additional 10 points will be awarded. Things to keep in mind during the competition. If during movement, one wheel goes off the path, the team will incur a penalty of -2 points for each violation. If both wheels go off the path during movement, the team will incur a penalty of -4 points for each violation, and the robot must return to the starting position. If one wheel goes off the path and the participant continues moving against the referee's instructions, the robot must be brought back to the starting position, incurring a penalty of -6 points. If the robot collides with the fences around the structures on the board during movement, the team will incur a penalty of -5 points for each collision. If during the execution of tasks, there is one collision with the security gate structure, the team will incur a penalty of -5 points for each collision. For the middle school board, during programming tasks, if there is a collision with an obstacle, the team will incur a penalty of -10 points. This is the illustrated part of the test with the following questions. The test is illustrated as follows. At Wind Power Plant 1, there will be 1 wind energy block. At Wind Power Plant 2, there will be 2 wind energy blocks. At Solar Power Plant 1, there will be 2 solar energy blocks. At Solar Power Plant 2, there will be 1 solar energy block. Each residential area needs to place a minimum of 1 energy block for each type and a maximum of 2 energy blocks for each type. The first team member to perform the task will start from starting position. This is the illustrated part of the test, the control section. In Residential Area 1, there is 1 wind energy block and 3 solar energy blocks. Since the maximum limit is 2, only 1 wind energy block and 2 solar energy blocks are counted. In Residential Area 2, there are only 2 wind energy blocks and no solar energy blocks. Violating the minimum requirement of 1 block for each type, no points are awarded. 1 violation of Area 1 and 1 fence fall at Residential Area 2. Successfully taking 3 wind energy blocks plus 45 points. Successfully delivering 1 wind energy block to the residential area plus 30 points. Successfully taking 1 solar energy block plus 10 points. Successfully delivering 2 solar energy blocks to the residential area plus 20 points. 1 violation of Area 1 minus 2 points. 5 violations of Area 5 minus 5 points. Total control section 98 points. Next is the programming part for the primary school board. The starting position for programming task of the primary school board is at intersection 2. And now, here is the programming task for the primary school board. After completing the programming section, let's calculate the total score for the primary school board. Robot moving from the intersection earns 5 points. Robot completing the return to starting point task earns 10 points. Thus, the programming part earns 15 points. Therefore, the total scores are as follows. Control section 98 points. Programming section 15 points. Total score 113 points. Now, let's move on to the programming part of the secondary school board. The illustrated test does not have obstacles, and the starting position for the programming task is at Gate 2, Solar Power Plant 2. And now, here is the programming task for the secondary school board. After completing the programming session, let's calculate the total score for the secondary school board. Robot moving to the intersection earns 5 points. Robot completing the return to starting position task earns 10 points. Robot stopping completely at the starting position 2 earns an additional 10 points. So, for the programming part of the secondary school board earns 25 points. Therefore, the total scores are as follows. Control section 98 points, programming section 25 points, total score 123 points. See you at the Myor 2024 competition where young talents in technology and robotics gather. Also, visit the Myor website regularly for the latest information about the competition. See you at the Myor 2024 competition where young talents in technology and robotics gather. Best of luck to all of you!